Hi guys, my name is Andreas Sava and today I'm going to explain the lava lamp experiment. Reactions occur only until one of the reactants runs out. This is referred to as limiting reactant. The materials that we will be using today is food coloring, an empty plastic bottle of around 28 ounces, some Alka-Seltzer tablets, and sunflower oil. I use this oil because it's a little more transparent than other vegetable oils and it's easier to see the reaction happening actually. Some background about liquids. Many liquids have different properties than you can see, feel, or taste, such as liquids are milk, juice, water, or oil. Each liquid also has other properties that might not be obvious because you can't see them easily. For example, they all have different densities. Juice and milk have densities similar to the water, so they can mix together, where oil has different density than the water, is less dense than the water, thus lighter, and thus it can float on top of the water, and the water stays on bottom without even mixing with one another. Liquids are made up of different molecules that have different chemical properties. Some molecules are polar, which they have unbalanced electrical charges, and thus they make them easily to mix since they attract one another. And some other molecules are non-polar, which have evenly distributed charges. These make it a little more difficult for the polar molecules to dissolve with the non-polar molecules. For example, water has polar molecules, oil has non-polar molecules. Even if you mix those two liquids together, and even if you stir them vigorously, they will never mix completely. They will be always separated because they don't want to mix together or stay together. In this video, we'll show the lava lamp experiment. But before I show that, I want to mention, as I said earlier, that the oil and water, they have separated in the bottle. We see that the less dense liquid, which is the oil, stays on top of the water, and the food coloring, which is a polar molecule, it's attracted by the water, and that's why it stays on the bottom. Water and food coloring, as we said, are polar, and they're strongly attracted to one another. Oil molecules are not. Um, we will have the same result if we try to put the liquids in a different order due to the properties of the liquids. So it doesn't matter in which order we pour in the liquid. When we drop in the Alka-Seltzer tablet, it sinks to the bottom. It passes straight through the oil with no chemical reaction occurring. When it touches the CO2, a reaction occurs where it releases carbon dioxide gas bubbles. These bubbles are less dense than oil and water, so they float to the top. As they float to the top, they stick to the water, dragging up some water towards the surface with them. When they reach the surface, the gas bubbles pop and the water droplets sink back to the bottom, creating a lava lamp effect. Eventually, the Alka-Seltzer tablet will be completely consumed and the chemical reaction will stop. So we can see here, Alka-Seltzer water is the limited reactant. If we let the bottle sit still, all the water droplets will sink back to the bottom. They don't want to mix with the oil, as we said earlier, but as long as we have more tablets, we can keep the reaction going. I'm going to pause here and I'm going to play the video so we can see the experiment. As we can see, the water bubbles travel to the top, they pop, and the food coloring pops comes back down again with the water droplets, and we see the reaction going and going and going until the Alka-Seltzer water is completely dissolved. We see there were the bubbles popping at the top and also in the bottom as they return back. We see the alka-seltzer here floating at the end and creating more rapid reaction. Thank you so much.